Super, let's attack this. The above is a schematic diagram of walkways. The below, the diagram is here, indicated by all the straight lines and lakes, 3 of them, each in the shape of rectangles, shaded in the diagram. So this is a lake. So lake, lake, lake. Different points on the walkway are indicated by letters A through P, A, B, C, D, E, F, G, H, with distances OP being 150, ON equal to MN equal to 300, 150, 300, 300, ML is equal to 400, which is nice, EL is equal to 200, which is nice, DE is 450. Sorry, not 450, 400. This is 1000, this is 750. Nice. The following additional information is given. The only entry exit point is at C. You can get through at C, leave at C. There is no other exits. There are many residences within the gate area. All of them are located on the path AH and ML, with 4 of them being at AH, M and L. AH and ML. With the house being here, residences being in each of these places. AH and ML. AH and ML. Post office is located at P and the bank is at B. So this is a post office at P and the bank is at B. Nice. That's it. There's nothing more than here. So we're not going to solve for something, complete it off, finish it off, find one part and then just mark down answers. Each question is going to provide the context for us for whatever we are doing. And so let's jump to the questions. Nice. One resident whose house is located at L needs to visit the post office as well as the bank. What is the minimum distance he has to walk starting from his residence and returning to his residence after visiting both post office and bank? And so L to post office, L to bank, they have to feature in some form, and then post office to bank. And the best way of doing this, this, and to bank is nothing but, there are no diagonal lines here. So bank to L is just this, and from post office to bank, let's calculate all 3 legs and then we'll see if we can optimize and make it any better. And so this is 300, this is 300, this is 400, the diagonal should be 500. Why? 3, 4, 5 triangle. 300, 400, 500. And 3, 4, 5 triangle, we know that triangle, right angle triangle, Pythagorean triplet. This is 150. So L to post office is 950. Bank to L, 300 plus 400, 700, 300,000, 1,200. Shortest distance from L to post office seems to be this. Shortest distance from L to bank seems to be that. In fact, bank I'm very confident because only non-diagonal lines. And this diagonal is useful. Yeah, both I'm confident. And the third leg is post office to bank. This is 400. This is 150. This is 200. This has to be 250. Why? Again, Pythagoras theorem. 3, 4, 5 into 50. 150, 200, 250. This is 400. 400 plus 400, 800 plus 250, 1050. The distance between bank and post office is 1050. Add all 3 up. 1050 plus 950 is 2000 plus 1200 is 3200. That's the one we're looking for. Nice. Let's go to the next one. One person enters the gated area. Nice. And decides to walk as much as possible without leaving the area, without walking along any path more than once, and always walking next to one of the lakes. Note that he may cross a point multiple times. How much distance will he walk within the gated area? And bunch of conditions. He enters the gated area, decides to walk as much as possible, leaving. So he enters at C leaves at C, right? And he will walk along any path without walking along any path more than once, each edge maximum once, and always walking next to one of the lakes. Right? Note that he may cross a point multiple times, he may cross F number of times, but he'll go on EF only once. Right? So, super. Now let's go around the lake. We start starting at C. We go like this, then we'll have to come back somewhere like this. So I'm going to go like this, and then straight, done, 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 done. If we do this, then every edge of every lake is covered. Very confident of this answer because this is 400, 300, circumference 1400, 200, 300, circumference is 1000, perimeter, not circumference, perimeter is 1000, 400, 300, once again 1400. Now, he should be always next to a lake, so none of these can be included. And he cannot go on any edge twice. The maximum he can do is the 3 perimeters. 1400 plus 1400 plus 1000, 3800. That is possible. That's our answer. Done. One resident takes a walk within the gated area, starting from A, returning to A, without going through any point more than once. What is the maximum distance she can walk in this way? Right? Maximum distance. So straight away I'm saying I'm going to look to avoid these two. Any point exactly once. So let's go this way and try to come back this way. Right? So this, E, L, M, cover G, covered A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Everything has been covered. We're not using any of these. Everything is covered only once. I'm going to find the total distance traveled. Then we'll worry about whether this is the best way or can we do more than this. So this is 1000. Likewise, this side is 1000. This, and this together add up to 750. This together add up to 750. So 750 plus 750, 1000 plus 1000, they are in. And then we have a 400, 400, 400, 400. 800 plus 800, 1600, 2000, 1500, 3100 plus 2000, 5100 meters. It's a maximum distance you can walk this way. I'm going to check this all over again. A, B, G, F, C, D, E. If I come back here, I'll hit F. No shape can be completed because you don't have to go to, shouldn't go to any point more than once. So I cannot have a complete square or complete rectangle ever. And so A, B, G, F, C, D, E cannot come back here. L. If I go here, then M becomes a dead end, cannot complete. M, N, K, J, O, P, and then back. And so distance wise, if I do step by step, 150, 550, 850, 1250, 1550, 2550. That way calculating is tough. So I'm adding these three, calling it 750, these three, calling it 750, this and this, 1000 and 1000. We missed out these two and these two, 400, 400, 400, 400, 1600 plus 1500 plus 2000, 5100 meters. Hopefully that is correct. Visitors coming for morning walks are allowed to enter as long as they do not pass by any of the residences and do not cross any point except C more than once. What is the maximum distance in meters that such a visitor can walk within the graded area? I come in through C, and leave through C. So C, I'll see touch more than once, but no other point more than once. Now, they do not pass any of the residences, so do not cross any point more than once. Residences, remember, are at AH. Residences are at AH and LM. So we should not go near AH, L, M, LM. We cannot go near that because there is a resident at A and at H, at L, at M. We enter through C and exit through C. How many places can we cover? We can go through each point only once. We'll go this side or that side. I'm going to start with the right hand side. C, D, E, F, K, N, O, P, I, J, E, B, C. We do this, we are covering every point except L, M, A, H. We are going to B, we are going to D, we are going to E, F, G. We are covering I, J, K. We are covering P, O, N. Covering every point. We're not using these diagonals. And we're going to C, entering through C and exiting through C. All good. We're not touching A, H, L or M. So what are the distances? This is 300. This is 300. 300 plus 400, 700 plus 300, 1000, 1200, 1600, 1900 so far. 150, 400, 150. 150 plus 150 is 300. 300 plus 400 is 700. 2600 till this point. 2800, 3200, 3500. We can do a total of 3500 meters. If we do this route, this seems like it's comprehensive. We're covering a lot of ground and we're not touching any point again. We're completely avoiding A, H, L and M, and we're not using any of the diagonals. Seems to be our best strategy. With this, we can get to 3500 meters. Lovely. 8 gymnastics players numbered 1 through 8 underwent a training camp where they were coached by 3 coaches: X, Zena, Yuki and Zara. X, Y and Z. Nice. Each coach trained at least 2 players. Yuki trained only even numbered players, while Zara trained only odd numbered players. After the camp, the coaches evaluated the players and gave integer ratings to the respective players trained by them on a scale of 1 to 7, with 1 being the lowest and 7 being the highest. Nice. Following additional information is shown. Zena trained more players than Yuki. 1 and 4 were trained by the same coach. 2, 3 and 5, the coaches of 2, 3 and 5 were all different. And so, now this statement, till this statement, I read this statement, I was not sure whether the same player could be trained by more than one coach. Is it a set theory type thing, Venn diagram type thing, or distinct thing? This says 1 and 4 were trained by the same coach, while the coaches who trained players 2, 3 and 5 were all different, suggesting that 2, 3 and 5 were by X, Y and Z in some order, hinting, therefore, they are different, that each coach trains a set of players. Each player is trained by one coach. I will not have player number 4 trained by X and Y. That's not happening. Player 5 and 7 were trained by the same coach and got the same rating. All other players got a unique rating. And so 5 and 7 same rating, 8 players, 7 different ratings. 5 and 7 got the same rating. Everyone else got a unique rating. That means all 7 numbers feature. 1, 2, 3, 4, 5, 6, 7. All of them feature. One number repeats. And that repeating number is whatever is there in 5 and 7. Only one number repeats. 1, 2, 3, 4, 5, 6, 7 feature. And then an additional one could be there. One of these 7 coming one more time. The average of ratings of all the players was 4. This is super useful. Sum of all the ratings is 32. We can find the repeating number straight away. Okay. Player 2 got the highest rating. Player 2 gets 7. 7 is definitely got by somebody. The average ratings of the players trained by Yuki was twice that of the players trained by Zena and 2 more than that of the players trained by Zara. Nice. Player 4's rating was double that of player 8's and less than that of player 5's. Nice. I think lots to play here with. So let's go step by step. Our data formatting is like this: X, Y, Z, which coach gets what. This is how we are going to capture the data. We're going to worry about average ratings at some point for X, Y, and Z and overall as well. Yuki trained only even numbered players, while Zara trained only odd numbered players. Yuki even, Zara odd. Player 1 and 4 were trained by the same coach. 1 and 4 could not have both been trained by Yuki, could not have both been trained by Zara. It's only even, only odd. So 1 and 4 are both trained by Zena. 2, 3 and 5 are all different. So 2 could not have been trained by Zara. 3 and 5 could not have been trained by Yuki because Yuki trained only even numbered players. 3 and 5 could not have been done by Yuki. That means 2 is done by Yuki. Done. Super. So we've got something filled in. Player 5 and player 7 were trained by the same coach and got the same rating. All other players got a unique rating. So 1, 2, 3, 4, 5, 6, 7 feature each of them once. And then one number repeats. What is the repeating number? Very nice. Average of all the ratings was 4. Average of 1, 2, 3, 4, 5, 6, 7 is 4. Bang in the middle. 7 numbers in a sequence. Middle number is the average. Overall average is also 4, or repeating number is 4. Or our ratings are 1, 2, 3, 4, 5, 6, 7 and an extra 4. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 7 into 8 by 2, 28. Plus 4 is 32. Average rating is 4, 8 people, total should be 32. And so repeating number is 4. So this person, 5 got a rating of 4, 7 got a rating of 4. Both are being trained by the same coach. Nice. Player 2 got the highest rating, so player 2 gets 7. Player 4's rating was double of player 8 and less than player 5. Player 5 rating is 4. Player 4's is less than player 5's and double of 8. So player 4 has to be an even number. Even number less than 4. So player 4 should have got 2. Player 8 should have got 1. Got 1, 2, 2 4s. So 3 is missing, 5 is missing and 6 is missing. 3, 5, 6 have to occupy these 3 slots. Brilliant. The average of the ratings of players trained by Yuki was twice that by Zena. If Zena average was X, Yuki's average would be 2X. And 2 more than that of the players trained by Zara. Zara's is 2X minus 2. Very interesting. So if this were 1, this will be 2. That will be 2 minus 2, 0. Not possible. This were 2, this will be 4. It will be 4 minus 2, 2. 2 is also not possible. X has to be more than 2. Maybe it is 3, 6, 4. Or it could be 2.5. Average need not be an integer. Just keep it in mind. It will be 2.5, 5 and 3. So other combinations also exist. So 3, 6, 4. X has to be more than 2. This is 2, this is 4. That is 2. 2, 4, 2 cannot have an average of, given overall average of 4 with any weightage. And X cannot be beyond 4. This average cannot be 8. Maximum number is 7. So X is greater than 2 and less than 3.5. Less than 4. 4, 8 something is not possible. Nice. So far so good. What could be the number of players trained by each of them? What values could X take? Number of players, we know that Zena trained more players than Yuki. So x and 2x we're taking a weighted average of, and then x we take with weightage for 2x minus 2 also, overall average should be 4. We know that between 3 and 5, one of these trained one, the other trained the other. And so Yuki is at least 3, so Yuki is at least 2, so Zena is at least 3. And so number of people trained by Zena is greater than or equal to 3, greater than or equal to 2. Lovely. Average ratings of Zara trained only odd numbered players. So if you look at odd numbered, 1 is here. Yuki has to have trained, Zena has to have trained 1 of 3 or 5. 2 odd numbers are taken. 1 is already by Zena, and of 3 or 5, one of the other ones has to be by Zena. So Zara could have trained a maximum of 2. So Zena is greater than or equal to 3, Yuki is greater than or equal to 2, Zara is less than or equal to 2. Nice. Three, 2, 2 adds up only to 7. We cannot have 3, 3, 2. This is more than that. So Zena is actually not greater than or equal to 3. It should be 4 or more. If it is 3, this can be maximum 2 because Yuki is less than Zena. This is less than or equal to 2. So Zena is 4 or more. Number of this greater than or equal to 4, greater than or equal to 2, less than or equal to 2. Nice. So 3 is not possible. If this were 3, this has to be less than 3, this is less than or equal to 2. So cannot add up to 8. So Zena could not have trained 3, at least 4, could be 5 maybe. 4 or 5, could be 4, 3, 1, 4, 2, 2, or 5 something something. I already feel like 5 is not possible because if we have 5, 2, 1 or 5, 1, 2. And now we have to weighted average of these 3 and get 4. Right? 8 people averaging out to 4. X, 2x and 2x minus 2. This is, let's say it is 4, 3, 1. 4x plus 3 into 2x, 6x plus 2x minus 2 should add up to 32. 4x plus 6x is 10x, 12x, 12x minus 2 is 32, 12x is 34, not possible. 34 by 12 being the average is not possible because there will be 4 candidates here. 34 by 12 is something by 3. That cannot be the average here. So we cannot have 4, 3, 1. 5, we had this as 5, this will be 5x. 2x and 2x minus 2 in the ratio 2 is to 1 or 1 is to 2. So 2x plus 2x will come twice over. 6x is guaranteed. It could be 6x minus 2 or 6x minus 4. 2 possibilities. I am doing x into 5, 2x into 1 and 2x minus 2 into 2, or 2x into 2, 2x minus 2 into 1. The 2x will come thrice, so it will come 6x, 5x plus 6x, 11x, either 11x minus 2 or 11x minus 4. Doesn't matter. 11x minus 2, 11x minus 4, both being equal to 32, x becomes a weird number. So with 5 it's not possible. So 4, 3, 1 is not possible. 5, 2, 1, 5, 1, 2. This being 5 is not possible. 11x is equal to 34 or 36. X is a weird number that simply cannot be the average here. And 4, 3, 1 did not work out either because there's no possibility for x as a legitimate value. And so if this is 4, then the average of these can be something by 2, a natural number by 2, natural number by 4, or natural number itself. It cannot be something by 3. Average x is what we are solving for, can be 1.25, 3.25, 3.75, 2.5, 3. It cannot be 3, 1 by 3. That's not possible. And because all of these are integers, sum of all integers divided by 4 cannot be something 1 by 3, something by 3. That's not possible. Cannot be a natural number by 3. So the x this number of entities here cannot be 5. It cannot be 431. It has to be 422. That means the number of people Zena has trained is 4, Yuki has trained is 2, and Zara has trained is 2. Give me a second. And overall average, give me a second. Overall average is 4x plus 2 into 2x plus 2 into 2x minus 2 equal to 32. 4x plus 8x plus this is 12x minus 4 equals 32. 12x equals 36. X equal to 3. This average is 3. This is 6. This is 4. 3 and 6 average, weighting average for number of units being 4 and 2. That average will be 4. This is 4. Overall average is 4. This works out beautifully. Zena has trained 4 people with an average rating of 3 overall. Yuki has trained 2 people with an average rating of 6 overall. Zara has trained 2 people with an average rating of 4 overall. Super, brilliant. Six, an average rating of 6 and 2 people. This is 7, so the other player should have got 5. So the other rating for Yuki ratings 7 and 5. Right. 2 people get 4 rating. Those 2 could be both Zara or both Zena. If they're both Zena, this will be 4 and 4. This will be 2 and 6. 6 and 2 should be 3, or the sum of Zena should be 12. 2, 4, 4 if it goes away. 2 plus 4 is 10. Other one should also be 2. We don't have another 2 to give. Right? Or these 2 4s cannot have been trained by Zena. They had been trained by Zena. 2 plus 4 is 10. The total should be 12. The other fourth number should be 2. That's not possible. We cannot have 2, 2, 4, 4. There's only one person who gets 2 rating. So this 4 and 4 has not been trained by Zena. It could not have been trained by Yuki. So both are trained by Zara. Yuki trains only even numbered people. 4 is taken. 6 is taken. This is not 5. So Yuki trains player number 6 with a rating of 5. Zara trains player number 5 and 7 with a rating of 4. So Zena takes 1, 3, 4 and 8. Adding up 1, 2. The missing 2 ratings are 6 and 3. This is 6 or 3 or 3 or 6. 6 plus 3 is 9, plus 2 11, plus 1 12. Zena's rating should add up to 12. That is good. Yuki's rating should also add up to 12. Player 2 and player 6 with rating 7 and 5 adding up to 12. That is fine. Zara's rating should add up to 8. 4 plus 4 both equal. That's also fine. We've got everything in the mix except knowing which one is 6, which one is 3. Both are trained by Zena. Both add up to 9. But we don't know who is 6, who is 3 between player number 1 and 3. And super interesting and challenging question, challenging set. What best can be concluded about the number of players coached by Zara? Exactly 2. Exactly 2. Done. What is the rating of player 7? Player 7 got a rating of 4. Nice and simple question. One of the earliest conclusions we drew. What is the rating of player number 6? Player number 6 got a 5 rating. Because Yuki could have trained only even numbered players. Yuki has already trained 2. Could not have trained 4 because that's trained by Zena. Could not have trained 8 because that has a rating of only 1. One rating is 7, another is 5. Player 6 coached by Yuki gets rating 5. For how many players can the rating be determined with certainty? Except 1 and 3. Everything else, 8 players, 6 of them we can know with certainty. Who were all the players trained by Zena? 4 players, not 5 and 7. 1, 3, 4, 8. 1, 3, 4, 8. Lovely. Let's go to the next one. Set 3. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 are placed in 10 slots on the following grid based on the conditions below. 10 slots 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 in the first row, 3, 2, 1. Numbers in any row appear in an increasing order from left to right. From left to right, increasing order. Okay. Numbers in any column appear in a decreasing order from top to bottom, or increasing from bottom to top. It increases this way, it increases this way. Right. One is placed either in the same row or in the same column as 10. Interesting. Neither 2 nor 3 is placed in the same row or in the same column as 10. Okay. Neither 7 nor 8 is placed in the same row or in the same column as 9. 4 and 6 are placed in the same row. Interesting. I want to see if there are more constraints. No, only these many. I think the increasing order like this and increasing order like this part are very interesting. And so the highest number, we need to worry about the highest and smallest numbers. Highest number is 10. 10 cannot be on the left. This were 10, no numbers there. This were 10, no number can be filled here. This were 10, increasing order, not possible. So 10 has to be here. If 10 is here, it has to be right at the highest number. This number is 10. Top right corner is 10. That's very interesting. Now we know that 1 is placed in either the same row or the same column as 10. So 1 could be here or here. Smallest number in that row slash column. Super. Now let's go. Located 10, increasing like this, increasing like this. Right? Neither 2 nor 3 is placed in the same row or same column as 10. So 2, 3, both have to be here. We could have 2 here, 3 here, 2 here, 3 here, 2 here, 3 here. I cannot have 3 and 2 like this, but several other combinations are possible. One should be either here or here. 4 and 6 are placed in the same row. 4 and 6 cannot be here. Could 4 and 6 be here? If I have 4 here and 6 here, then 2, 3 will have to come here. Those are remaining options for 2, 3. This cannot be here, 4 and 3. That's not possible. So 4, 6 cannot come in the third row. 4, 6 cannot come in the last row. So where could 4, 6 be? 4, 6 could be in this row or the first row. My gut feel tells me that they should not be in the second row, they should be in the first row. So I'm looking to eliminate second row. Second row, this cannot be 4 and 6 because 2, 3 have to be accommodated in these 3 slots. Right? So this can be 4, 6 like this or 4, 6 like this, or 6 comes here for sure. One of these two has to be 4. Right? If this were 4, this has to be 5. 4, 5, 6 is the only possibility. If this were 4, 5, 6, then 2, 3, there's no room for 2, 3. So this is not 4, 5, 6 like this. So I'm going to say erase 4, 5. This has to be 4. Right? Now we could have 3 and 2, 2 and 3, either way. Neither 7 nor 8 is placed in the same row or in the same column as 9. Now 9 has to be accommodated. 9 has to come, cannot come below here, cannot come here, 9 cannot come here, 9 has to come there, not just 9, 7 and 8 also have to come here. You need to have 7, 8, 9, 10. It's the only possibility. The moment we say 7, 8, 9, 10 are the only possibility, 7, 8, 9, 10 have to be in one row. That doesn't work. So this possibility is also ruled out. Nice. Top left or bottom right, row 2 or 3 without going to the last column. Row 2 would have to be 2, 3 in the first 2 columns. We made these inferences. I'm going to carry on and say row 1 or row 2. If 4 and 6 were in row 2, then 6 would be last column and 7, there's no room for 7, 8 and 9. So row 4 and 6 have to be in the first row. We've already seen that we cannot have 4, 6 here. Could have that we put 6 here, 4 here doesn't work. 4 here means 5 has to be in between. That also doesn't work. No room for 2, 3. If 4 were here, no room for 7, 8, 9. So 4, 6 have to be in the first row. Four in column 1, row 1, or column 2, row 1. So we can put 4 here or here. 4 can be here. So 4 can be here or 4 can be here. If 4 is there, 6 has to be there. Right? Now I'm already thinking the 7, 8, 9 constraint could run into trouble. So I put 4 here, 6 here, 9 has to be here. Because if I have 9, I cannot have anything between 9 and 10. 9 has to be adjacent to 10. And it can be some other thing where it doesn't interfere, but it has to be adjacent to 10. I cannot put 9 here, then there will be nothing to put here. I cannot put 9 anywhere here. Right? If 9 is there, then 7 and 8 cannot be in the same row or same column as 9. So 7 and 8 cannot feature here, cannot feature here, cannot be here. They cannot be here either because it's an increasing order. There's no room for 7 or 8, or 4 cannot be here. This whole thing doesn't work. Super, so we've narrowed down to this. 4 has to be in the top left, which means 1 has to be here. Brilliant. Now we know that we can say 6 can be here or here. Second column or third column. Let's put both and we'll process it. If it is the third column, 5 has to be here. 4, 5, 6 have to get filled like that, which means once again 9 is here. If 9 is here, neither 7 nor 8 is placed in the same row or same column as 9. 7, 8 cannot be here, 7, 8 cannot be here. Both have to be here. That's not possible. This is also ruled out. Or we are down to 4, 6, dash 10, and then 10 dash dash 1 in this column. 2 and 3 have to sit here. That much we know. Super. Now let's look at 9. 9 were here or here. Let's say 9 were here. Then 7 and 8 cannot come here, cannot come here. We have to have 8 and 7 accommodated. We put 8 here, 7 here. This is an increasing order. This also has to be an increasing order. With 7 we cannot accommodate an 8. It is not possible. 9 cannot be here. Right? 9 here or 9 here are the only two possibilities. If I put 9 here, 7 and 8 cannot be here, 7 and 8 cannot be here, 7 and 8 have to be here. This is 8, this is 7. Then there's no value can sit there. So that is out. It has to be 4, 6, 9, 10. Which means 8 and 7 have to come here. If 8 and 7 cannot be in the same column or same row as 9. 8, 7 have to come here. So we filled beautifully. 7, 8, 9, 10. 6, 7, 8, 9, 10 are done. 1 and 4 are done. 2, 3, 5 are remaining. Which is super useful because I know 2, 3, 5 have to come here anyway. 2 cannot be here. 2 can be either here or here. And so we can put 2 here, 5 here, 3 here. That's a possibility. Or 2, 3 here and 5 here. That's not possible. Because 5 cannot be here. 5 has to be in the top row. And so 2, 5, 3, this is possible. Or we could put 2 here. This will be continue to be 5. This will be 3. 5 cannot be here because 2 and 3, one of them cannot be here. 5 cannot be here because 2 and 3 cannot be here. Again, ascending order conditions are violated. 5 has to be there, which means we could have 2, 3, 5, 2, 3, 5 like this, or 2, 3, 5 like that. That means this, and this are frozen. 2 and 3 can come in, plot like this, 2, 3 or 3, 2. Both options are open. Brilliant. Now that we have gone this far, I'm just going to answer the question. What is the row number which has the least sum of the numbers placed in that row? Row 4, sum is 1, done, true. Which of the following statements must be true? 10 is placed in a slot in row 1. Yes, that is true. 1 is placed in a slot in row 4. Yes, that's also true. 10 is in top right, 1 is in bottom right. Both are true. Both 1 and 2, choice A. Which of the following statements must be true? 2 is placed in a slot in column 2. No, 2 could be in column 3. 3 is placed in a slot in column 3. No, it could be in column 2. Neither 1 nor 2. Done. For how many slots in the grid, placement of numbers cannot be determined with certainty? These two. What are the sum of the numbers placed in column 4? Column 4 is fixed. No variability here. 10 plus 8, 18, 25, 26. To the next one. An online e-commerce firm receives daily integer product ratings from 1 through 5 given by buyers. Daily and integer ratings. The daily average is the average of the ratings given on that day. Nice. The cumulative average is the average of all ratings given on or before that day. So day 2 you'll get daily ratings. Day 2 you'll get cumulative ratings. That is all ratings till day 2 and ratings on day 2. Day 1 daily rating and cumulative rating are same. The rating system began on day 1 and the cumulative averages were 3 and 3.1 at the end of day 1 and day 2. So day 1 average is 3. Day 2 average is something such that day 1 and 2 put together average is 3.1. The distribution of ratings on day 2 is given in the figure below. Oh, lovely. With this we can find average for day 2. Then we know the weighted average of day 1 and day 2 is cumulative till day 2. We can find something else beyond that. Let's do this. 10 buyers gave a 5. This is 50. 20 buyers gave a 4. 80. 5 buyers gave a 3, 15, 10 buyers gave a 2, 20, 5 buyers gave a 1, 5, 5 plus 15, 20, 20 plus 20, 40, 40 plus 15, 90, 90 plus 80, 170, divided by total number, number of people, number of buyers, this is 10, this is 20, this is 5, this is 10, this is 5. 5 plus 5, 10, 20, 30, 50, 170 by 50. Brilliant. 170 by 50 is 3.4. Weighted average of 3 and 3.4 should give us a 3.1. Daily rating for day 1 is 3. Daily rating for day 2 is 3.4. Overall is 3.1. Number of people who have given ratings on day 2 is 50 people. Super useful. Nothing more is there. 100 buyers gave product ratings on day 3. The modes of the product ratings were 4 and 5. Modes are most frequently occurring. 4 and 5 occur most frequently and equal number of times. It's bimodal. The numbers of buyers giving each product rating are non-zero multiples of 10. So 10, 20, 30, 40, 50. Those could be the ratings. Ratings for 1, 2, 3, 4 and 5 are all multiples of 10. Each of them is 10 or more. And non-zero multiples of 10. The same number of buyers gave ratings of 1 and 2 and the number is half the number of buyers who gave a rating of 3. Oh, nice. This is day 3. Ratings of 1, 2, 3, 4, 5. X people here, same X people here, 2X people here, Y and Y. Y greater than X. Because 4 and 5 are the modes. 100 by 5 is 20. If all were equal, it should be 20. That's not even the case because these are more frequent. It should be more than 20. Or Y should be at least 30. It could be 40. It cannot be 50 because 4 and 5 ratings were given by 50 and 50 people. There will be nobody here. That's not possible. So the number of people giving 4 and 5 cannot be 50 and 50. Cannot be 20 and 20. Is more than 20, less than 50, 30 or 40. Could be 30, 30. And then X, 2X. X plus 2X is 4X people. In this case, the remaining is only 20 people remaining. So should be 5, 5 and 10. That's not possible. The number of people giving each rating is a multiple of 10. So this is also ruled out. Number of people giving 4 and 5, if each of those were 40 and 40, then 80 people give 4 and 5. 20 people remaining for giving 1, 2 and 3. Each of this is a multiple of 10. Not possible. But 30, 30, number of people, 10, 10, 20, 30, 30. 10 people give 1, 10 people give 2, 20 people giving 3, 30 people giving 4, 30 people giving 5. Total number of people is 100, mode 4 and 5. This into 2 is this, these two are equal, done, true. So day 5 data we know completely. Sorry, day 3 data we know completely. How many people gave what ratings? Brilliant. Now we can find average for day 3, cumulative, etc, 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 etc. And let's crack this grid. Two types of data sets. We've captured all this data. Number of people who give 1 is 5. Number of people who give 2 is 10. We've done all this math. If we add all this up, 130, 150, 170, add all this up is 50. So overall average is 3.4 for day 2. The 3 and 3.4 are mixed together to give a cumulative rating of 3.1. They should be mixed in the ratio 0.3 is to 0.1 or 3 is to 1. 50 units on day 2. Then on day 1 we should have had 150 units. Ratio is 3 is to 1. We're mixing 3 and 3.4 to get 3.1. Right? In what ratio are we mixing this? We are mixing in the ratio 3 is to 1. There are 50 units here. It should be 150 units. On day 1, there are 150 buyers giving an average rating of 3. On day 2, 50 buyers giving an average rating of 3.4. On day 3, there are 100 buyers whose average also we can find. Modes were this. We did this. 4 and 5 should have each occurred 30 times or 40 times. Could not be 40. Has to be only 30. So day 3, we have to put day 3 details. Ratings of 1, 2, 3, 4, 5. 10 people, 10 people, 20, 30, 30. Product is 150, 120, 60, 20, 10. Add all this up. 270, 330, 350, 360. 360 by 100 is 3.6. So day 3 average rating is 3.6. Number of entities is 100. Super, we're done. We've got exactly the total number and rating for day 1, day 2, day 3. The day 3 individual splits and day 2 individual splits also we've got. How many buyers gave ratings on day 1? 150, we know this. What is the daily average rating of day 3? 3.6, we know this. What is the median of all the ratings given on day 3? Totally on day 3, 100 ratings were given. So average of 50th and 51st rating when you arrange them on a stack. 10, 20, 40, 50th and 51st ratings would have both been 4. So how do we arrange this? So we have 1, 1, 1, 1, 10 times. 2, 2, 2, 2, 10 times. 3, 3, 3, 20 times. 4, 4, 4, 30 times. And 5, 5, 5, 30 times. This is the ascending order of everything put together. Median of this is the average of 50th and 51st terms. 10, 20, 40 terms, till 40 terms, 1, 2, 3 are completely out. From the 41st term to the 70th term are all 4s. So median is 4. Which of the following is true about cumulative average ratings of day 2 and day 3? So day 2 cumulative average rating is 3.1. This we know. Day 1 cumulative is 3. Day 3 cumulative ratings all put together by the total number of entities. So this 3 into 150, 450 plus 170 plus 360. Add all this up. 0, 12, 18, 8, 1, 5, 6, 9, 980. divided by 300. So cumulative rating is 980 by 300, 98 by 30, 49 by 15, 4 by 15. Right, so 4 by 15, 15, what decimal is this? It is 3.4 by 15, 26 something. Nice. The cumulative average of day 3 increased by less than 5% from day 2. Day 2 is 3.1. 5% of 3.1. 5% of 3 is 0.15, a little more than 0.15. I think it's more than 5%, not that. Increased by more than 8% from day 2, 3.1, 1.08. No, that's also not true. This I want to verify, but this is not true. Average of day 3 increased by a percentage between 5% and 8%. Decrease from day 2. This is wrong. To get the detail right. And so I'm going to do this by this. 98 by 30 divided by 3.1. Let's do that fraction and think where it is going to be. 98 by 30. 98 by 93. 98 by 93 is more than 5%. 105 by 100 is 5%. 98 by 93, going from 93 to 98, the percentage increase is 5 by 93. More than 5%, less than 8%. That's true. See. I have a calculator, I'm just punching in, getting the value, seeing it as maybe 5.3% or 5.4%, marking the answer. Two plots below give the following information about 6 firms A, B, C, D, E and F, 2019 and 2023. PAT, the firm's profits after taxes in rupees crores. E is the firm's employee strength, that is the number of employees in the firm. PRD, the percentage of the firm's PAT that they spend on research and development. I want to have one look at what is being shown. PAT ES 2019, PAT ES 2023, 6 firms A, B, C, D, E, F, 6 firms there, all good. And then the PRD, we'll have to figure that out. The plot the horizontal and vertical coordinates of point representing each firm gives their ES and PAT values respectively. Horizontal is ES, vertical is PAT. The PRD values of each firm are proportional to the areas around the points representing each firm. So, like bubbles around the dot, circles around the dot, the area of the circle is proportional to the percentage of PAT spent on R&D. The areas are comparable between the two plots, that is, equal areas in the two plots represent the same PRD values for the 2 years. What do they mean by this? That is, if this area is 1 and this area is 5, then it is x and phi x, not x and phi y. The scale across both of these as far as the area is concerned is the same. Now let's get to this. We'll have to find a way of measuring and tracking this area. This unit is sitting inside this. If this circle, I'm calling that as 1. This radius, half of this thing, that is as 1. Then this A is twice that radius, so this will be 4. F is twice that radius, that will be 4. B is thrice that radius, 9. C is thrice that radius, 9. 1.5 times. This is half times, 1.5 times, 1 time, 1 time, 1.5 times. This is 2 times, 4 times the radius, 16. Nice. Here, this is 4, 4, 4, 9. This is same as this 4. This is 9. There's no 16 here. This 1.5, 1.5. 1, 1, 4, 4. Yeah, 4, 4, 4. Super. So now we've got this ratio plonked in properly. We know this is PAT, this is ES. There's nothing to solve here. Each question is going to ask us something about PAT and employee strength and PAT per employee and PRD per employee per this, whatever. We'll figure that out. Right? Percentage of PAT is given proportional to this. This is not 1% of PAT is not an R&D. If this were 1%, this is 4%. It could be 3 and 12. Right? Lovely. Assume that the annual rate of growth in PAT over the previous year remained constant over the years for the 6 firms. Annual rate of growth remained constant. Which among the following firms had the highest ARG? They're talking about average or CAGR, it doesn't matter. So they're basically saying do 2023 PAT by 2019 PAT. Whichever is highest, that's our answer. And we don't need to find the value. Firm C has PAT of 3000. Firm C had PAT of 2400. 30 by 24 or 15 by 8. B had PAT of 3800 by 2800. 38 by 28, 19 by 14. 30 by 24 is 5 by 4, not 15 by 8, 15 by 12, 5 by 4. These two are close enough. Let's do the other ones. A is 3900 by 3000. 39 by 30, 13 by 10. This is 1.3, this is 1.25. 19 by 14 is probably higher than both of these. E there is 3500, E here is 2400. Is 35 by 24. 5 by 4 is 1.25. This is 1.3. 19 by 14. 5 by 14 is more than 1/3. This is higher. This is 11 by 24. Even higher. 35 by 24. My gut feel is 35 by 24 is greater than 19 by 14. 35 into 14, 19 into 24. We can find that 35 into 14 is 0, 7, 490, 24 into 19, 19 4 is 76, 6, 7, 38, 45. For me, all we are doing is this PAT by this PAT, 4 ratios, finding the answer after that. The ratio of the amount of money spent by firm C on R&D in 2019 to that in 2023. 19 to 23, firm C is 9x times, whatever the 9x is, 9x percentage of 2400 is to, here it is 4x percentage of 3000. (24 is to 30 is 4 is to 5. This 4 gets knocked off, this x gets knocked off, 9 is to 5. That's the answer. Done. We don't know what is the percentage, we don't need to know. We know that the areas are equivalent between these two. Whatever this, if this is 4x, that is not 4y, that's also 4x. That has been clearly given here through. Which among the firms A, C, E and F had the maximum PAT per employee in 2023? Firm C, PAT per employee. C is here 3000 by 800. 300 by 80, 30 by 8, 15 by 4. I don't care about the units as long as I'm consistent. I don't care about the units at all. Firm A is 3900 by 1300, which is 3. Firm E, so we'll draw a line to A, just lower PAT, higher employee, I'm not even calculating. F is similar to A, maybe up a smidgen. F is 3200 by 1000, 3.2, just 3.75, just done. If you draw a line through A or through F, A is slightly below it, E is much below it, C is above it. this ratio, this line talks about the ratio. Obviously, this line passing through 0 talks about the ratio, but we understand that. Right? So, therefore, C, higher PAT for fewer employees. That's our answer. Which among the firms C, D, E, and F had the least amount of R&D spending per employee in 2023? Least amount of R&D spending per employee 2023. Firm D is here. 4 into 2400, 4% of this number, 4x% of this number by 800 in some form. E, 9 into 3500 by 1400. I'm already thinking E will be the answer, because that number 9 it pulls more weight than this ratio can. Sorry, least number of spending. So it's not E. I'm not saying E is the answer. I have to very worry about this. E or B would be closest if it were maximum. E, I think we can eliminate them. C would be 3000 into 4 by 1000. 3000 into 4 by 800. Nice. This is 4 into 2400 by 800. This is 4 into 3000 by 800. This is also low. So far it is D. We need to compare D and F. F is 4 into 3200 by 1000. This is 4 into 3, 12. 4 into 32 by 10. 4 into 32 is 128 by 10. This is 12.8. Least should be 18. 2400 by 800 is 3. 3200 by 1000 is 3.2. Least is firm D.